Hey guys, so I wanted to work out some of the problems on the Unit 8 test review. I know I was seeing a lot of stuff today, being Monday, where you guys were struggling on remembering the stuff from before break, which totally makes sense, but I want to make sure that we're staying on top of our stuff, especially as we're outside of school. You got to make sure you're checking in, doing your homework, and studying those notes. Take the notes and study the notes. So if you're still a little bit lost, reach out to me, but go back and watch the Vertex form notes from the Monday before spring break, Tuesday before spring break, and then look at your old notes for standard form and all that stuff, because that's really the only way you're going to help get this is if you practice it and study those notes. So this first video, I think I'm going to look at problems 1 through 12, try to get through those with you. Won't do all of them, but should hopefully do enough to help click how to do these problems again. All right, so remember the axis of symmetry is the vertical line that goes through your vertex. So if I draw my vertical line here, it goes through my vertex. It's the x coordinate, so it's x equals 1. The vertex is the point that it goes through. So the vertex is 1, -9. You'll notice your vertex is a minimum because it's the lowest point of the parabola. And the minimum value is -9. Okay, so there might be some questions like that down the line. So x-intercepts are where your parabola crosses the x-axis. So we can see there's one. There's another one. Another way to identify your x-intercept is that your x-coordinate is something, but your y-coordinate is 0. Okay? So we have those two x-intercepts because that's the both times that your parabola crosses the x-axis. All right, and then your y-intercept is where it crosses the y-axis. So it's what happens when you plug in 0 for x, you get out -8. Okay, so that first part's identifying the parts of a parabola, making sure we can look at a graph and get the vocab, or look at the vocab parts and be able to graph them, okay? So 5, 6, and 7. Now we're going to use a table to answer the following questions. I'm going to look at, let's do number 6. Okay, so if I look at number 6, if I want to determine what the y-intercept is, remember the y-intercept is what happens when the x-coordinate is 0. So if I look right here, that's my y-intercept because the x-coordinate is 0. So 0, -7, that's the y-intercept. All right? The x-intercepts are what happens when the y-coordinate is 0. So if I look in my y column, you'll notice that y is never 0 explicitly. We don't see 0 in the y column. So instead, what I can do is I can say, okay, in between here, it goes from -1 to 1. So that means it's going to have to cross over 0. And similarly here, we have 1, -1. So it's going from positive to negative. It's got to cross the x-axis. So since they are not nice points, what I can say is that the first one is it's going to be between 1 and 2. Because the x-coordinate's right here, between 1 and 2. That's going to be your first x-intercept. And then your second x-intercept is going to be between, I'm just using the abbreviation BTWN, between 2 and 3. Okay? So I think the other two are a little bit easier than that one. All right? But the x-intercepts are when the y-coordinate is 0. All right? And remember, for the most part, we're going to use our graphing calculator to find the x-intercepts. But we'll get to that, I think, in the next video. All right? And then the last question says identify the vertex. Well, if you remember from our graph up here, the vertex is the highest or the lowest point. So it's where that axis of symmetry goes through. So what I'm going to do is I'm going to look for symmetry in my table. If you'll notice, what I mean by symmetry is where do the y-coordinates repeat? Okay? Because if I look at the graph, this y-coordinate is 0. if 1, 2, 3, it's 3 units to the left of the axis of symmetry. So 3 units to the right needs to be another point. So that's where that symmetry comes into play. So if I look at my table, here I've got a -7. Here I have a -7. So there's symmetry. Here's -1. There's -1. And it's all surrounding this point of 2, 1. So that's going to be the vertex. It's not saying that -17, -31, -49, -71, so on and so forth on the y. That's not saying they don't repeat. They do repeat, but it's just not on our table. Okay? But there's still going to be all that symmetry surrounding that vertex of 2, 1. Okay? So hopefully that helps you try out 5 and 7. Let's look at what's next. Answer the following questions with a 1-sentence description. So this is seeing, okay, if I give you a graph, how has that been transformed? So if you remember our transformations, just to show you, these are our 5 transformations. And remember, they look at the A value, the B value, the C value. Those can tell us what's going on if it's in standard form. So if I look at this, how is the graph of g of x equals 1/3 x squared related to the graph of f of x equals x squared? Well, you want to look at what's different. Well, what's different is that our A value is now 1/3. So what that means is, just think, if I have Play-Doh, if I want to make that 1/3 of the height, I'm going to push it down. So this is a vertical compression. We're compressing it. We're making it smaller. Vertical compression. Okay. Next one, how is the graph g of x equal -x squared? How does that relate back to the parent function of f of x equals x squared? Well, what's different? The A value is now negative. And do you guys remember when we were doing that activity in class, if the A value becomes negative, your parabola opens down now. So the graph, and that's called a reflection. So the graph is reflected. That's that key word there, because the A value is negative. All right, and then we look at g of x equals x squared plus 4 related to the graph f of x equals x squared. What's different is that our C value is now 4. And remember, our C value is the y-intercept. So my y-intercept changed from 0, 0 to 0, 4. So think about it. Your parabola was at 0, 0, and now your y-intercept is at 0, 4. Okay? So all your parabola did was it vertically shifted up 4. Okay? So that's how we do those problems. We'll get to transformations a little bit more in the next video as well. And then to wrap up 11, 12, and 13, determine if the graph has a maximum or minimum. Then state the minimum or maximum value. Okay, so if I look at 11, what we want to do is first determine if it's a max or a min. So we look at the A value. So if you'll notice, the A value here is 1, which means the A value is positive, so your parabola is going to look like that, which means what we're dealing with is a minimum. Our vertex is a minimum. Okay? Now, if we want to find the minimum or the maximum value, we actually need to find our vertex. So the first thing we're going to do is find our axis of symmetry. If you remember, our axis of symmetry formula, if it's in standard form, is x equals negative b over 2a. So if I do this, x equals negative, our b value is 4, over 2a, our a value is 1. So x equals negative 4 divided by 2. So x is equal to negative 2. So that's the x-coordinate of my vertex. To find the y-coordinate, I just plug it back in. So y equals, put that in parentheses, And if I simplify this, I'll have 4 minus 8 minus 2. 4 minus 8, that's negative 4. Negative 4 minus 2, that's negative 6. So this is my vertex value. Okay? And the max or min value is always going to be the y-coordinate of the vertex. So the minimum value is going to be negative 6. Okay? Now, that works a little bit differently when we're dealing with vertex form, because you remember in vertex form, we got, this is vertex form. This is the one from the video notes that I did before spring break. Okay? So that's vertex form, and the vertex is HK. All right, and this works a little bit nicer to find the vertex in this form. So the H value is what follows the subtraction sign. So notice how the 2 follows the subtraction sign. So that's the H value. The K value is 1. K value is positive 1. Okay, so that's my vertex. It is a maximum. Because the A value is negative, that means our parabola is going to be opening down. It's going to be a maximum. And the maximum value is going to be 1 because it's the y-coordinate of your vertex. Okay? So that is the first video for this. Try out the other problems. Let me know if you need something else. The next couple videos, we'll be looking at actually graphing these in standard form, vertex form, and then we got to look at applications. Okay?